Okay, the purpose of this video is to show you how to quickly set up a 2D problem in Autodesk Simulation Multiphysics 2012. I'm going to go to Override Default Units. I like to use English units. Make sure the system is English inches. Click OK. Make sure that it's going to do a linear static stress with linear material models. Click New. Give it a name. This is going to be 2D How To for myself. Now, first thing you've got to know, if you're doing 2D, you've got to draw your part in the YZ plane. Okay, so first thing before anything else, go to Planes and click Plane 2, YZ plus X. It will not recognize 2D elements if you do it in another plane. Let's go to Draw, and I'm just going to draw a simple figure here. I'm going to go to Line, use Relative. Now this time, make sure you leave checked Use as Construction. For beams and trusses, you uncheck Use as Construction. For this one, we're going to leave it checked. I'm going to start at 0, 0, 0 is my starting point here. Got my starting point established. For Y, I'm going to go dy. Let's go 12 inches in the Y direction. I'm going to go 6 inches in Z. I'm going to go minus 2 inches in Y. Minus 4 inches in Z. And then I'm going to go, let's see, I believe it's minus 10 inches in Y. And then just close off my L shape here. All right, so that's my part. I'm going to go to Element Type, double click on it. This is going to be 2D. Okay, now let me show you again. 2D's third one from the top. If you don't see 2D, you're not in the right plane. Okay, default they give you is plane stress isotropic. Okay, that sounds good. We'll leave it compatibility not enforced. We can enforce it. It'll take it longer to solve it. I'm going to stick with the defaults on this. For thickness, let's make it 1/4 inch thick, 0.25 inches. Click OK. For material, let's just use aluminum 1050 H14. Aluminum 1050 H14. Click OK. All right, so we've got our part. We talk a lot in FEA modeling about meshing. Where's the mesh? Well, if you click on mesh, okay, we don't have any options here. What's wrong? Well, what you want to do is click down here on, basically this is the components that make up your part. Right click on that, then you'll find Create 2D Mesh. So what I did, again, I expand the part, completely expand it right here where it shows the geometry, the different geometric part, things that make up the part, the different lines. Right click on that and go to Create 2D Mesh. Now we have some options. There's quadrilateral, mixed, or triangular. Mixed will be a mix of triangular in some areas, quadrilateral in some areas. Let's just do quadrilateral. I'm partial to triangles, but quads will be a good exercise for us. We can select a different mesh density. Let's leave everything for now as it is and click Apply. And you notice it has generated a quadrilateral mesh now. Okay, so we need to apply a boundary condition and a loading. So I'm going to apply a boundary condition to the left side and put a loading up here on this part. Now we're working in 2D. So what we're going to need to do is select a surface. So I've got surface. Select this surface here. Right click. Add surface boundary condition. And for this, let's just do what I call brute force and just completely fix it. Okay? Completely fixed. I'm going to go to this surface here. Click it so it's highlighted in this case, pink or teal. Okay, add. We can do a surface pressure traction. So let's do a surface pressure. Okay, now if you know what the force that is applied to it, let's say it's a point load, you know it's 500 pounds, you can calculate the area of that surface and then convert it to pressure. I'm just trying to do something really simple to give us some experience in how this works. So I'm going to have basically a distributed surface load applied as a pressure, magnitude 100 psi, and let's see, it'll be normal to the surface. We'll click OK. It's showing a letter P. Okay, so we've got that pressure load applied. This should be enough for us to solve our problem. So I'm going to click on Analysis and Run Simulation. And again, the purpose of this is just to show you quickly how to set up this type of a problem. All right, we have results showing von Mises stress. It's occurring at a maximum right down here. The blue is very little stress at all. Well, we can look at individual stress tensors. Let's say if we wanted to look at just the X component of stress, okay, or Y component of stress. Let's look at Z component. Okay, now if we're dealing with a brittle material, we might want to look at the maximum principal stress. Since we're dealing with aluminum, von Mises is good. We're showing a maximum of 3,245 psi. Now, we would need to do a back of the envelope calculation to make sure our results make sense. I'm not going to take the time to do that in this demo video. Before I do anything else, though, I am going to check displacement. And displacement seems reasonable, 0.02 inches, okay? Now, as I'm looking at this, I would like to go to View, and I do want to see my loads and constraints. You'll see where the pressure is acting and the direction where our constraint is applied.